Hello everybody, here is a question which I just made up. When I say made up, I don't mean no one's ever done this question before. I'm sure this question's been done. I just mean I thought of it now. I didn't copy it from anywhere else. This is the question. We've got two lines that are 10 centimeters. They're connected, let's say, by pivot. They can open or close, and no matter what the angle between them, we connect them with a third line, obviously forming a triangle. And the question is, at what point is the area of that triangle maximized? Or to rephrase, to maximize the area of the triangle, what angle between the two lines will maximize that triangle? What's that length of the third line? And what is that maximum area? And this is what I love about mathematics. It's about solving real world problems, such as you want to build a trough and two sides are the same, but maximize area. I know I recently did a question with cylinders and minimizing costs. That's why math is useful. Those of you who've seen my questions before have seen I have papers set up on a table. Something interesting here, I seem to have one row over here, a paper there with arrows. Why did I do that? Well, think of it this way. You have to travel from point A to point B, and there's more than one way of getting there. You will still start and finish at the same points. You will start at A and you will finish at B. Same thing here. Here's a question with more than one method. You will still start and finish at the same point. Even if there's a different way of getting there, both methods land up with the same answer. Oops, I'm giving away the answer before I even get there. I shouldn't be doing that, but it's too late. I've given away the answer. Anyway, let's get on to the question. There are more than one way of solving this, as I said. One method requires knowledge of calculus, the other of trigonometry, and I'm going to start off with the calculus method. What I do is I drop a line that goes halfway between the bottom line in the middle of the 2 points. I call this H and I call this X. One thing we do notice, these two triangles are congruent. Side, because it's isosceles, another side, because I dropped in the middle. And as it's isosceles, these angles are the same. Side angle, side's enough proof. Therefore, these two angles are the same. And if they add up to 180, it means they are both 90 degrees. I'm trying to do it now with a pencil while I'm talking. Okay, so those are two 90-degree triangles. So let's start with the question. I'll show you why it's necessary to know that. I make an equation starting with area. It's calculus. It's that area I want to maximize. That's why the subject of my formula must be what I need to maximize. I chose the letter V. I could pick any letter. I guess A would have been a better choice if it's area. I was just thinking of this upside down letter V. Anyway, the formula for area of a triangle is half times base times height. Half base is X because they're both X here. So half base times height is X times H. There's X times H. As always, or not always, but usually we have a problem with more than one variable. We want to find a way to relate X and H so we can get rid of one of them. And there's my triangle. What do we notice? Pythagoras. That's 90 degrees. X squared plus H squared equals 10 squared. There you go. X squared plus H squared equals 10 squared, which is 100. Now, I usually check to say which is easier to isolate. But here they're both the same, X squared, H squared. There's XH. So it's equal. So I happen to pick the H squared. I bring the X squared to the other side. H squared is 100 minus X squared. And so H is equal to 100 minus X squared to a half. I rooted both sides. I could put a root sign, but as it's a calculus question, I find it easy to use the exponent. And now we substitute in. That's the whole purpose of isolating that H. There's area. Instead of X times H, it's X times this bracket to the half. X times 100 minus X squared to the half. I substituted in for H. And now it's time to do the derivative. And as I said, I kept the exponent sign instead of the root sign because it's easier for derivatives. Derivative says left derivative times right. And of course, every course might differ. Another course, they might say right times left derivative. There's many correct ways. I always say nearly always do the way your instructor tells you. Left derivative of x is 1. Left derivative times right. I don't change the right. Plus right derivative. I use chain rule. Half times bracket to the minus a half times derivative of the inside, which is minus 2x. Because we bring that 2 down and subtract 1 from the exponent, times the right. Right derivative times left, I beg your pardon. The left was x, there's the x. And I like to put a mark to show there L is prime, that's left derivative times right. There's right derivative times left. I like to pencil that in because if there might be a mistake, it's easy for me to go back and check. That's a personal choice. As always, do it, usually nearly always do the way your instructor tells you. Now we simplify. We can do away with this 1. And this bracket stays the same for now. Minus 2 times a half is just 1, which I don't have to write in. X times x is x squared. And that minus approaches, so it's like plus minus. Now we simplify further. That left stays the same. And I just write minus. Instead of saying the bracket, the minus a half, it's to the half at the bottom. And now we find a common denominator, which is bracket to the half. Now, as the denominator was multiplied by bracket to the half, we multiplied by the same bracket to the half. When we multiplied it, we add the exponents. Half plus half is 1. So we've got 100 minus x squared to the 1 on the top. And on the right side, the denominator did not change, so that minus x squared stays there. So we've got 100 minus 2x squared. And as it's a derivative that we are setting to 0 to solve for that area, we can multiply out that denominator. So we've got 100 minus 2x squared equals 0. And now we solve for x. Therefore, 100 equals 2x squared. Divide each side by 2. So x squared equals 50, and therefore x equals 5 root 2. I wrote that 50 as 5 times 2, so we can see 5 times 5 root is 5. 2 rooted is root 2. X is 5 root 2. And to solve for that h, I use my friend called Pythagoras. H squared plus 5 root 2 squared equals 10 squared. Therefore, h squared equals 100 times 5 root 2 squared. 5 root 2 times 5 root 2 is 50. 5 times 5 is 25. Root times root 2 is 2. 25 times 2 is 50. So we've got 100 minus 50 equals 50. H squared is 50. H is the root of 50, which is the root of 25 times 2. Root of 25 is 5. So h equals 5 root 2. And there's the triangle we filled in. H is 5 root 2. X is 5 root 2. Now to find that angle, remember that this is an isosceles triangle, 5 root 2 and 5 root 2. It means these two angles are the same. Any triangle, the three angles add to 180. If that's 90, we've got these two add up to 90 and are the same, means 45 and 45. So this angle is 45. These two triangles are congruent. That means that's also 45. That means this angle at the top is 45 plus 45, which is 90 degrees. Now to answer the question, the angle on top is 90 degrees. As I said, the angle between the two lines. That third line is 5 root 2 plus 5 root 2 is 10 root 2, because these two triangles are congruent. It's 10 root 2 centimeters. And the maximum area, it's half times base times height. Half base is 5 root 2. So it's 5 root 2 times 5 root 2. And 5 times 5 is 25. Root 2 times root 2 is 2. So that maximum area is 50 centimeters squared. Now to do it the other method, my favorite funny little green arrow. Another formula for area of a circle is half AB sin theta, which is the angle in between the two sides. So it's half times 10 times 10 times sin theta, which is 50 sin theta. I think that angle is theta. Let's call it squiggle in case I'm wrong of that angle. Now, that sin of theta can take on many values. If it's between 0 and 180, the maximum value the sin of angles can take is 1. And that occurs when that theta is 90 degrees. Therefore, that top angle is 90 degrees. If you visualize this angle opening up opposite over the hypotenuse, if that's swinging around, that opposite over hypotenuse maximizes when that line is vertical and that opposite is sitting on the hypotenuse. One can even do calculus, find the derivative and set that sin equal to 0. So if we know that top angle is 90 degrees, means this angle is 45, that's also 45, and of course we know that's 10, so we can use Pythagoras, like a squared plus a squared is 10 squared, and we solve for that 5 root 2 and that 5 root 2, and we get back to the same answer. That angle in between is 90 degrees. That third line is 5 root 2 plus 5 root 2 is 10 root 2 centimeters. And that maximum area is 5 root half times base times height, 5 root 2 times 5 root 2, which equals 50 centimeters squared. That's solving it 2 methods. And I hope you enjoyed this question. I loved doing it for you. There we go. There's all my papers, and talk to you all soon.